Okay, so for exam 2, this is going to be an exam review, and we're going to do a problem very similar to this, and I'm going to work through it, and hopefully this won't take too long, but I did want to record it as a separate video, even though I was going to do this in class tonight as the exam review session. So what I'd like to do is sort of like merge the things that we've learned so far together into one particular problem, right? To assess whether you're getting the essence of what we're trying to do. So I've picked this problem because we did cover it in class 12, or at least we began to, and I don't think I made a video for that class, and I had wanted to. So anyway, so this kind of serving those purposes here. So let's use what we learned in class 12, or what we were supposed to at least, to synthesize these points. And we're going to use the online version, the online tools, and then we're going to try to find the velocity and acceleration for an input of 60 RPM, which seems to be, just an easy number to use. So we're going to use one of the legs is 60 RPM, and we're going to use the tools that we've generated in Excel and also do the stuff by hand. All right, so we want to get this big picture of actually designing a mechanism to perform a task. So that's what exam 2 is going to be. And it's a take home, so hopefully with these tools right here, I want this to be doable, and I want you to everybody to get 100 on this. So let's walk through it. So I'm going to go to useful links and resources here and go to mechanism links, and we're going to go to that wonderful Motion Gen app. Now I thought about using the stuff out of chapter 5 and my spreadsheet, but I had limited my spreadsheet to a two-position analysis, a two-position synthesis. And then as I started to go through problems, I noticed that I was having issues with trying to use my spreadsheet in a universal way, so that every time I tried to do a new problem, there was some little quirk and so forth that I couldn't expect a student necessarily to have picked up on, not based on what we had covered, and because we hadn't done a homework problem in it yet, I couldn't make the exam that way. That's why I delayed this review session, because I wanted to get this just right. I don't want to give you something that is not possible to do. This is not what this class is about. I actually want you to absorb and understand how to make mechanisms and make mechanisms do the stuff that we intend them to do. All right, so I've placed in this example in here, and I'm going to trace over many of these things, and it just occurred to me that I haven't remembered how to do a couple things, but let's go anyway. All right, so over here on the right hand side, I tried to do this in class once, and it didn't go well because you couldn't see this very well. You see, I'm grabbing this tool that looks like this right here, and I'm going to place it right here. In fact, this is actually what that tool is for. We're going to place it in these 3 spots. Right? These are called precision points. All right, now I'm going to go onto the finger tool here. And this first one, he's already in the correct orientation, but he needs to be turned. So I'm going to grab him and get him into the same orientation, right? So we're using that precision point and we're getting it aligned. And we're doing the same thing over here, okay? Because that's what they've determined are going to be the spots. Now, I'm going to come back over to this tool and expand it, and I want to... there you go. I had to click it a couple times until I got that dashed line to turn into that base. Now, this type of problem is going to be in chapter 5 and section 5.8 that called synthesis for a specified fixed pivot location. So in that analysis, and we didn't cover this because it's a lot more mathy, but here we're going to be using an app to generate the thing instead of using like a spreadsheet, or actually probably need some MATLAB code because it's a simultaneous solution or matrix solution thing to be able to do this. Instead, we're doing it with an app. And so to do the same thing, they have 3 position points and then 2 ground points that have been decided for us. So we put it right there and right there. And in here, they've already decided where the location of the grab-a-hold points were A and B. In the book's solution, or in their method, that was something that you could choose. Now, I'm going to just tweak these. Now, if you tweak these too much, it'll get screwed up, but it'll let you do it a little bit right here. Right, just a little bit, right? So it hasn't really changed. Right there, okay? And I think we got everything lined up. So if we were to place it here, okay, so it's going the wrong direction. We want it to go this direction right here, right? And we could also go back to this guy right here, and we can move him back and forth. So now you see we've designed a mechanism, and this one can do a 360. So, and we also see that it's a little messed up because I think our tweak might have messed up. See, it doesn't line up exactly on that precision point, and belying the name precision point, isn't it? So let me see if I can tweak this a little bit. I'm going to move it, grab it down. It's still okay. So the hold on points, maybe they're not as important as keeping this orientation right here, right? All right. So I think he's decided to go the wrong way. I want him to go that way. You're not going that way, man. You're not doing what I'm asking you to do. Okay. Well, we know we can get it to go there. We get to go through there. Yeah, so it's made its round to get into those points. All right. So now, okay, so we've got this, and great. But what can we do with it? Well, let's export it. Well, we can export it in 2 different ways. We've already exported it once as a GIF, whatever you want to call it. Let's do it as a PDF. All right, so this is something you're going to want to keep and upload. And let's click onto this and see what happens. Okay, they give us a little graphic. But more important, they give us constraint data, right? So these are going to be like the locations of... let me double check what they're going to be locations of. Sorry, like I said, I didn't pay attention. Now, one thing we should know, that when we input this right here, we didn't give it a scale. So it is scaled against something. So we're going to have to go backwards to figure out what that is, and then scale it up to our desired scenario. And we also we could also generate a GIF if we wanted to, and probably should. And so we'll let that go ahead and do that just for posterity, just for something to save. So we got pivot information. And so we're starting at these points, and we have joint information, and they're giving us the location of the joints. But here's the important part right here. Here's the one that we're going to probably end up needing to use the most and to scale up, right? That we're going to have the ground link, the crank, and the coupler, the follower. I think they mean the rocker right here, and then the coupler fixed length. And they're also going to tell us where the position of the degrees. Okay, so we're going to have to interpret what all these mean, and I'm going to have to mess around with this just a little bit to try to check myself. So I'm going to pause while I do that. And I don't want to do that live because I'm going to look like a moron, and I don't like doing that. Okay, so what these mean, these are the coordinates of the points that we picked out right here. each individual one, and then you could see, and then these are the angles that I rotated them, right? So we say 315 degrees, which wasn't too bad because this one, right, was 45, so that's definitely there, 315.8. And then this one was like 270, so that looks like we did a pretty good job, right, in terms of the orientation. Of course, this is always going to be approximation because we just pick these things on a screen. But we can take a look at these and scale them up into, so I think that when so the other things, we have these lengths down here and these locations of these different joints, right? So they have where each of these pivot joints are going to be. And then we also have these lengths of all these legs right here. So you know what would probably be a useful thing to do? And so this is I'm giving you the step-by-step instructions, or what I would do when trying to use this utility, this engineering tool, would be to save this someplace. Let me go to, I think I'm going to solved problems. And I forgot which problem this was in here. Let's see. This was I can go back into here and see it somewhere. Solved problems. This was well, it was from Figure 5.4. I believe that makes it 520. Is that right? Come on, show me. Yeah, 525. Okay, so I will save this as, well, it's already 525. 525B. Okay, because I've already done this once. All right, so I did that so that I could open it up over here in my where my SolidWorks is located. Although I could do this, I do have the student version on this machine. So anyway, I'm going to open this into here where I just put it through my OneDrive. All right, so let me split my screen over here with my SolidWorks, and it doesn't like to do that. It really doesn't like to do that. Come on, why not? It likes it a lot better when I have two monitors. But let me move this. I'll scrunch this one a little smaller so I can read it. I just want you to be able to see where I'm getting the numbers. So what I'm going to do is I'm going to create a sketch right here on this, in the front plane, and I'm going to enter in the points right here. I have my units set as inches, right? So I entered a point, and now I will just enter in what the coordinates are. 1.224 and 7.490, enter, right? And I'm still selecting that point is still active, so I'm going to make it fixed right there because I don't want to move it around if I draw a line and attach it to something. Okay, so now I'm going to pick another point right here, and that's going to be my second one down, and I'm going to go 6.312. And this is kind of boring, and you're going to get the idea here that I'm going to put all these in. So maybe I should pause the video again, maybe? I don't know. You can just fast forward. I think that's what you'll do. I think so. I got those in there, right? Okay, and then I'll put this other point and 7.117. And in the y coordinate, it's going to be 2.551. Okay. Now my pivot constraints, those are going to be these points right here. Oh yeah, and I forgot to fix it. There you go, fix my little anchor in there. That's what, and at Merchant Marine Academy, the anchor was the insignia for the deckies, and we as engineers were propellers. And we didn't like that. What the hell just happened right there? That was not what, it just changed values. Oh, I know. Because I didn't create a new point, right? So I was trying to talk at the same time. So I create that point. So the other one, I was trying to adjust a point that was fixed. and it was jumping back to what it was before. 3.506. So we won't try to tell stories about Merchant Marine Academy while we're trying to do work. That's just silly. And nobody cares. Let's see. Okay, and I'll do this other point right here. I don't know where it's going to end up, but it's going to be 4.029. Yes, and a 3.193. Boom. Okay, and I'll fix that point. Let's scroll down, and we can get where the other joints are located. Some of these should be the same points, shouldn't they? The fixed pivot on the driving link. Let's see where this one lands. This is sort of an exploration. I'll just point it anywhere here. And we're all right. 3.5064. And I could probably just copy and paste these probably. I wonder if that works. Let's see. Let's try it on the next one. Boom. Wait, did it land in the exact same spot? Yeah, it did right there, right? Oh, yeah. Yeah, it makes sense. That was silly. Okay, yeah. Of course it's going to be the same spot. Dummy. All right, and so I could probably undo that because now I have 2 points right there. Yeah. So that's going to land in the same spot. And let's see. This one down. Yes, the one down at the very bottom is also, there's a fix. So let's make, while we're here, let's make it to the moving, let's see, hopefully that's not a point that we already used. No, I don't think so. This is the moving point driving link. Well, that seems pretty low right there, or pretty further left. Let's see where that ends up. 1.7088. Oh yeah, I said I was going to try this. Let me see. Is it going to let me... Control C, Control V. See, look at that. I just made my life like a little itty bit faster. Control C. Whoops, an error occurred in the clipboard. Well, bite me. That's not very nice. He didn't like it. Yeah. Is he going to do it? He did it anyway. All right. Even though it was a... Oh. Bounce back. Oh, that's because I didn't create a new point. I keep forgetting. Create a new point, man. Create a new point. All right, now do it. Yeah. Whatever. I don't know why I didn't like that clipboard thing. Oh, see, we can do it. Oh. All right, well, so we're going to enter them in by hand, I guess. How can it work the first time? It didn't work right there. Okay, we'll wait. Okay, so that looks like it's a point that we already used. And you guys are probably watching this go, that's that point we already used, dummy. I'm like, oh, all right, check it out. Okay. Let's see, these, that's the coupler endpoint. Yeah, that makes sense. Duh. Yeah, that's a precision point. That's in the posture that's in right now. And then we have the moving pivot right here. Let's try this one. And of course it's mad at me. And then let's go to another point right here. And well, I actually got kind of close to where the thing was supposed to be. And right in there. Okay, so these should give me right there. Okay, so if I take a look back up here, what I've done is almost like we're stargazing right here. If we go from here to here to here to here to there, right? And from here to here. Okay, great. Now, so these are the precision points right there. Now, the distances, we could also check, by the way, down here below. I believe they're giving us all of these. But we could just check them, right? And it says that this one is 3. We make it driven. and give it some decimal places, and you can see that we get, pretty close, right? 3.0018, 3.0019. So that's what these all this stuff means inside these charts. And now the question is what to do with it. Well, now we can make our 4-bar in our other tools, right? We could use our other tools to try to navigate this. All right, so yes, one of the difficulties is this is moving clockwise, and all of our tools have been going for counterclockwise. So in order, and I don't want to have negative time, so in order to use our tools, we might want to do that same thing where we flipped it backwards. All right, so let me pause again and see what I want to do. Whoop. Pause again. Okay, so here's what we can do. Because we have a totally different scale, and we don't quite know what that scale is. What we should do is try to figure out what the scale is, so that we could use these linkages and we could scale them up, right? Because we're given the linkage lengths, but those lengths are just going to be proportional, and we want to accomplish this task that we were set out to do. So what would make sense, I think, when you want to scale something is take the largest thing that you can measure on there. And I think that's going to be, and let's see, I'll zoom in on this guy. Let's see, let's go. Why can't I just go, Control plus? Will that work? Yeah. The largest extent, let's see. This is really making me a little mad here. Okay, I can't. There you go. I'm getting a little bit of the dummies going on. 211 right here is the distance between this point and this point down here. And then 180 is the vertical distance, right? So we should be able to scale that point to that point, and in the horizontal direction. And by the way, we fixed the thing so they're driven. We can increase the number of decimal places. You can see we could also, by the way, we could also have just subtracted out the stuff off of here to figure that out. We didn't have to use these dimensions, but it's just a little bit easier to explain, I think, using these dimensions. Or maybe for a visual learner like me. So anyway, okay, so what we could do now is we could take a scale of these things, and you don't need to see me do this, but I could go take a comparison, but the calculator's not really big. Why do you have such a big calculator? I used to have this calculator that I bought at Ocean State Job Lot. That was just huge. It was a solar-powered huge thing, and I used to bring it to class, and if someone forgot their calculator, I would call it the calculator of shame. All right, so we take 211 and divide it by our 5.892, don't need any more decimal places, we get 35.8112. So anything that we get in terms of the dimensions, we would multiply by 35.811. But we had two places that we could measure. So we have another scale that we can check. And so if we do that, we could take, and I need to move this guy over to the side, 180 right here and divide it by the 4.9, whatever the hell it is, divided by 4.939 equals 36.44. So I got 35.81 and 36.44. It's not terribly too bad. What I can do is I could take the average of those, right? So I can add back my 35.81127, whatever, doesn't matter, equals, and then divide by 2. All right, so now I have 36.12. That's going to be my scale, 36.12. it's not a high precision thing, but we're probably, when we would go to make this, we might try to pick like real dimensions. It depends how precise we need to be, really, in terms of our precision points. But now we have an idea of what the output of this engineering tool is and what we can do with it. We also need, though, because of the way that we've set up our spreadsheet, unless we want to completely recreate our spreadsheet, we really need to get the ground link on the horizontal, right? So what we're going to need, let's see, push this guy back over to the side again. Yeah, I want you. And we need these angles. They probably might even tell us these angles somewhere in here, right? The orientation of this. Length in inches, value degrees, maybe. Yeah, it's probably the ground link is the one that we want to try to get. But they gave us 179. We have to be able to interpret what these things are. I'm guessing that 122 is going to be up here. So let's check out what that one is. I bet that's 122 right here. Yeah, that's the 122.86. Sure enough. Which might be something good to know, right? Maybe. We're a little bit different. I want to know about, with respect to ground. Let's draw the ground. Let's draw the ground link in here. And let's see what this angle is. That's going to be something that we're going to want to know right over here. All right, so that's something that we didn't have, that we want to kind of, we want to shift this whole thing so that it's like, it's going to look a little silly, but that's the posture we want to have right there. So I want to write this down. I'm writing it down over on a piece of paper. 127.32 degrees is how we want the orientation to be able to get the thing that we want. I want to take some of the other dimensions just to double check on some of them, because I don't necessarily trust a lot of things. Let's see. That link is, we get driven 1.2999. That's a lot of nines. Yeah, that's the coupler right here, right? You'll see that the coupler arm length, right? So that's going to be our AP, by the way. So here's our crank, here's our AP, here's our del that we use in there, and right here is going to be our coupler length. Well, let's get another sig fig in there. That's going to be 1.416, right? That's this guy right here. That's good. Okay. And then I think we need this guy right in here. I think I'm in line 29. Yep, this right here. So that's this guy right in there. Oh, sure enough, he's pretty close, pretty close. And then lastly, we want this ground link right here, right? Well, not lastly, I got a couple other things I want. That's going to be, yeah, 0.8625 according to this. This gave me 0.8626. That's good. Now I want this link and that link, and I want that angle. There you go. There's the all-important 179. Boom. Right? With that driven, and we could have actually, if I could grab him, we could even get a couple more decimal places. Why not? In there. It sometimes having lots of sig figs and in between things is a good thing. We don't want to have too much round off here. All right, so we've established what all these things mean, except maybe this following angle. Follower angle. I'm not quite sure what that is right here. But PAB. Okay, so maybe that's the angle that's inside here. Let's check that out. That's 29. Okay. It's almost 30 degrees right in there. And then 19. It doesn't let me go. Let's see. I want to get rid of him. Yeah. How about this guy right here? Any chance? He doesn't quite look right to me. Nope. 27. So I'm not quite sure what that 19 is. But I did write down that 127. But while we're here, we might want to save this image, right? So I'm going to go ahead and do a little screen capture here of my what I have right here, and it might be worth keeping track of these things. And I can come back over to here, and then I'll pause my video again. Okay, so here's our Excel spreadsheet that we had for acceleration. We're going to have to do some serious modifying of this, so we make sure we made a copy of it. And so this is the one without a graph on it, and where I have the example that we previously did. So there's lots of different things that's going to take place in here, so we have to be a little adaptable. First off, it's not going to be in millimeters. Second, let's put in our value. It's going to be in inch. Let's say that. Actually, it didn't tell us what it was, but it's chances are that's in inches. It looks like that's kind of the size of the thing. So let me put this over to the side right here, and all right. So our link lengths. These are kind of, well, let me open up this, let me open up the thing we saved previously, right? In the, when I got solved problems, and I call this one right here, all right? So this is the data from the data sheet right here. Let me, I'll put that guy over here to the side and go back over to here. Okay, so right in here, because this is a good spot for it, I'm going to come in and write down the numbers they provided instead of the numbers that I measured on there, because might as well. I really just did that to try to, I don't know, trying to confirm what all these values were. But let's see, the ground is going to be 0.8625, right? That's the information they gave us. The crank is L2. That's the 3.0018. The follower, that's the rocker, all right? That's going to be, okay, so now we have to be careful that's going to be actually L4 is the follower, right? They're calling that the rocker. That's the 2.9705. Double check that with my thing right here. You can see, yes, that's the one. Now, right here, that's going to be, the next one down is the coupler fixed length. You notice they go AB right there. That's going to be correct for us. So we go 1.4161. And then the AP, well, they even call it AP right here. That's 1.3008. Okay, and so our theta 2 relative to our starting off point, right? So the crank angle, by the way, you notice that is the angle at which 04, 02, and A, right? Just remember that that's going to be 04 is this guy, 02 is this guy. If you could see my little, let's see, let's make a little shape right here. This is always considered, where's my colors, damn it? Right there, that's 04, this is 02, and this is A. So that's the 179.45. So we're at 179.45. Whoops. Yeah, well that's the right. Okay, and then also our del is 122.8. You know, if we actually should probably use, like we said we were doing, let's go back to this guy, and we see the 179.52, and our del 122.8. 0.86. Okay. Our scale, I'm going to write this up at the top for myself. I'm going to write scale equals, and we could have done this in Excel too. I mean, we could have calculated the thing and put it someplace. I'm going to go 36.12 was our average scale. Therefore, now I'm going to enter in right here equals that times this, but we want to make sure we go do F4. Boom. And I just scroll this down. And I'm a little nervous. Let's see what happens over here. Boom. All right, so this right here, obviously it's laying over to its side, but if you can imagine, that is our orientation right there, right? You can see it. It's laying over the side. Now what we want to do is try to get the velocity and acceleration of this point, tracking at the 3 precision points, right? The 3 locations of the precision points. So I'll pause the video again. Okay, some additional information I need to get. I want to make sure I'm still recording this. Yes, I am. Okay. I forgot. I actually deleted this thing. I had to recreate it again because sometimes just don't make good decisions. All right, so what I want to do, I have to try to get this thing so I could find the angle, because from what they gave me, I don't have enough information to figure out the angle, I don't think I do, of the angle of the crank when the thing is in these precision point locations. I don't think they gave it to me. So I drew the little triangle over here, and I'm going to try to manipulate this. So I make that equal to that, this leg equal to, hold on, control, to, oops, let's see if it'll do it. Okay, that has to equal that. All right, boom. And then this has to, hold down, has to equal that. Let's see, oops. Let's see, I'll do it again. That one has to equal this dimension. All right, so that's the triangle right there, and I think no matter what, it'll be correct. Because they have 3 sides, so I'm gonna. I almost want to copy them again. I got to do it a second time. So I place it right here, and what I'm going to do is I have a couple different choices in how I would do this. I think the main one I'll do is I'll set this equal to that, and I believe that's the orientation that it has to make. Is it black? Yeah, that's the only orientation it can make. Now what I could do is I could check by grabbing those, and that should be black. Let me check and see and make sure this is the same length. Yep, 2.97. Okay, so that worked. And I'm not saying this is the way that you would always do things, right? So when you get out into the real world, you'll start to find that there's never like you always run into a variety of ways to do things, and very seldom do you have, at least I don't know if I could say that. You probably work for some company where they have everything is written down exactly. Do this and do this and do that. I know that for an electric boat, it was kind of like that. Although the jobs that I ended up having in underwater shock analysis group were often, there'd be like we'd have to like invent some way to do it. Okay, so here's the point right there. And I'll make the crank again back over to that spot, and we should make that crank equal that crank. Boom. Oh, look at that. Okay. And let me double check that I got it right by grabbing that point and bringing it back over to this point. And if we set that one equal to that one, whoop, 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 whoop. It doesn't like it. It can't be done. There's something wrong. Okay. Let me double check. Undo. That one, I think it might accidentally be collinear or something. It says that I'm 100% defined. Let me just see if I can I? Oh, I don't want to set it equal. I want to double check its length. Okay, yeah. And that should be, yeah, okay. So I double checked its length. That's right. Okay, so I knew that it was like close to being 180 degrees, but here's the angle right here of the total sweep. So it goes to 163.68. So that's all we really want to. We want to get that angle. Right? We only want to go that far. But maybe I think when the question I'm going to ask you is actually to find the velocity at the middle, at the second point, because that's going to be interesting. Because we probably would put a driving dyad onto this. Although this orientation, if we take a step back and look at it, remember what we did with driving dyads, that's going to be a little difficult to have a driving dyad do this this motion, because it goes to 164 degrees. That's interesting. But let's see. Here is the actual angle that we're going to want right there. All right. So we want to find what the velocity and acceleration of this point P is going to be when it's at 87.9.09. All right. So we might as well just say like 87 degrees. That's fine. Right. So that's why we're doing this right here. Okay, so I'll come back and I'll show you how we're going to use this with Excel. Okay, so in Excel, what we want to do is we want to find the positions and velocities only from this starting off point to the finishing point, which we found to be 163.7 was our finishing point. So what we're going to do is we are now going to start right here. So I'm going to replace the 0 cell with this angle right there. And boom. And now I'm going to make the increment -5 degrees. And I am going to stop it when it comes to, oh, well, we got to figure out what the finishing one is, right? So we start at 179.5, and we actually want to subtract out 163, right? So we might actually want to go for a finer increment, because we're going to we're not going to do 360 degree study of this. So we go 179 what did I say on here in the actual one here? 179.52 minus 163.68, right? And okay, so we're going to get close to 0, right? 179.52, 163.68, and subtract out. So we end up with 15.84, right? So anywhere in the 15 to 16 range is going to be fine. So we come down and we see what we get right to there, right? It only takes a little bit of time. So what do you say we make these increments of negative 2. It doesn't matter, right? We don't have as many points as for, a lot good points, more points are better. Let's go -1 degrees, and we're counting down, and right down to there. Okay, so we're going to stop this thing at 15.5 right here. Okay, so I'm just going to delete everything from there down. Right, remember we're adapting a tool. Let's take a look at our thing over here and see. Okay, so one thing, because it's kind of skewed, right? So if we want to get a better, these should all be circles, or a lot of these should be circles. Yeah, these two should be circular, right? So we don't have, our scale is a little off, but that's okay. You can get the idea of what of the position of each of these things, right? But this is the end point for this piece, right? So what we want to do for our analysis, right? We want to, and by the way, is our time working out here? It looks like time is counting downwards. And by the way, we want to be careful here. I think I said I want to go 60 revolutions per minute. You know, that's actually really fast if you imagine how fast this thing would be moving, right? You wouldn't want to move this thing so that it went 1 revolution per second, right? Because it's not even going to do a full revolution if we're talking about this thing being the speed of this piece right here. We probably want to go something along the lines of just fractions of that, wouldn't we? Well, let's just make it 2 radians per second. That's still going to be probably really fast. But it's going to be going clockwise. So let's see what will happen if we go -2 right in there. Yeah, we get minus time. So let me pause again and do the calculation and figure out what we have to do to resolve that. I keep meaning to do that because we want to go, it is doing decreasing, so it's going in the correct direction in terms of the angle. It's just that we want to get a time that corresponds to this. And so we want to start out with 0 time, and we want to increase it based on the angular position at a constant velocity. So let me think about that. Okay, so here's the logic. We need to start off at 0, right? And so what I want to do here is I want to always be referencing this first cell right here. So I'm going to set this guy right here. This is the degrees, and we're going to get smaller and smaller from him. So I'm going to take that, and I'm going to make that an F4 right here. So now we always be this top cell right here, where we take this and we divide it by that, is always going to be the reference. So now I'm going to take and do the same thing again. I'm going to take this, but that's this new cell right here is going to be able to vary as we go down, and I'm also going to divide by this angle right here, but then we want that to be F4 again. And I think if I make it minus right here, I'm going to get a 0 right here, and if I double click down right there, I should get increasing time and a positive increasing time. So what I've done, and I think maybe I forgot to mention, I made the increment negative right here, and I made the omega negative, right? So now it's going clockwise. So it should be moving, and we double check over here. Yes, sure enough. And so now when we go to, and it makes sense that the AY right here is going to be negative. So so we've set this up now so that we can do our analyses. We have to be careful here, though. I just noticed again on that last little bit right here. Remember, the last little increments don't count, right? So when we go to do this, if we're going to do make a graph of these. We have to be careful that that doesn't count right in here. And let me double check that I ended up going the amount. Yes, 15.52. So far we have achieved everything I think that we want. And we want to try to compare it. We want to do, this is we should have our velocity and acceleration analysis, but we don't know for sure. So we have to do hand calculations. So up to this point is what you're going to have to do for a new piece, right? Not the same, but there's going to be a different assignment, and that's going to be the exam. But one more aspect. We want to get when the thing is at this point, that in-between point, and find the velocity and acceleration. So that's going to be what we said, 87 or thereabouts, 87 degrees. So coming down and scanning down through here, we find that it's going to be right around there. It's actually in between, but we're going to say that's good enough. And so what you need to do, and we need to make sure we're looking at the right thing. We have theta 2, theta 3. All right, those are the important ones, and we want to get and then we also want to get omega 3 and alpha 3. Right, you need all of those things, I believe, in order to calculate the APX and the APY by hand. Or we also want the VPX and the VPY by hand, and the VPX and the APX and the APY by hand. And we want to confirm these values right here, right? So I want you to do all of the analysis by hand, right? So you could get the thetas, right? We're going to use these thetas right here. Says you don't have to do the position analysis, but you do have to do the acceleration analysis. So let's put this on pause, or should we just go publish? Let's publish and make a different video for that, because it's already 50 minutes long. But I think I've gone through and explained everything, and I'll do that again in class today. Thank you.